What is the radius, r, of the circle? Line constructions, geometric theorems, trigonometric identities, cosine rule, arithmetic and algebraic operations are used to solve this question. Label points C, D, E, and G. Join line D, G, and let angle G, D, equals theta. By Pythagoras' theorem, the square of DG equals the sum of the square of DE and the square of EG. Substitute values and take the square root of the equation. We have that DG equals to 5 units. By trigonometric identity, DE divided by D, G equals 4 divided by 5, which equals cosine theta. It follows that cosine theta equals to 4 divided by 5. We call it equation 1. Join line CG. Since angle CDG equals the sum of 90 degrees and theta, by cosine rule, the square of CG equals the sum of the square of CD and the square of DG minus 2 times the product of CD and DG multiplied by cosine 90 degrees plus theta. Substitute values. We have that the square of CG equals the sum of the square of 9 and the square of 5 minus 2 times the product of 9 and 5 multiplied by cosine 90 degrees plus theta, which equals to 106 minus the product of 90 and cosine 90 degrees plus theta. We call it equation 2. By trigonometric identity, cosine 90 degrees plus theta equals negative sine theta, as shown on the screen. Substitute it into equation 2. We have that the square of CG equals the sum of 97 and 72 times sine theta. We call it equation 3. Locate the center O. Join line OC and line OG, where each equals to the radius, r, of the circle. It implies that reflex angle COG equals 2 times angle CDG, which equals 2 times the sum of 90 degrees and theta. This result is equals 180 degrees plus 2 times theta. This is because angle at center is twice that at the circumference of the circle. From triangle COG. Angle COG equals 360 degrees minus the sum of 180 degrees and 2 times theta, which equals 180 degrees minus 2 times theta. It is because sum of angles at a point equals 360 degrees. By cosine rule. The square of c, g equals 2 times the product of the square of r and cosine 180 degrees minus 2 times theta. By trigonometric identity. Cosine 180 degrees minus 2 times theta equals negative cosine 2 times theta. We call it equation 4. Substitute into the above equation for the square of CG. We have that the square of CG equals 2 times the product of the square of r and the sum of 1 and cosine 2 times theta. We call it equation 5. Since equation 3 equals to equation 5, equate them for the square of CG. This implies that the sum of 106 and 90 times sine theta equals 2 times the product of the square of r and the sum of 1 and cosine 2 times theta. We call it equation T. From triangle GDE. Sine theta equals EG divided by DG, which equals 3 divided by 5. By trigonometric identity. Cosine 2 times theta equals 1 minus 2 times the square of sine theta, as shown on the screen. Substitute value of sine theta. This signify that cosine 2 times theta equals to 7 divided by 25. After substitution of derived value. From triangle GDE. Sine theta equals 3 divided by 5. Substitute the obtained values into equation T. This implies that the sum of 106 and 90 times 3 divided by 5 equals 2 times the product of the square of r and the sum of 1 and 7 divided by 25. Simplify. We have that the sum of 106 and 54 equals the product of 64 and the square of r all divided by 25. Hence, 160 equals the product of 64 and the square of r, all divided by 25. Cross-multiply and make the square of r the subject of the formula, so that the square of r equals the product of 160 and 25. All divided by 64. Take the square root of the equation. Hence, r equals to the square root of 106 times 25. All divided by 64. Which equals the product of 5 and the square root of 10. All divided by 2. Therefore, the value of the radius, r of the circle is equals to the product of 5 and the square root of 10. All divided by 2. In units.